Dear students, today we'll see the fourth part of our multiple choice questions on the subject industrial automation. And in this fourth part, we will see multiple choice questions on inverters. So let's start question number 61. Now this question says that inverter converts. Options are DC power to DC power, DC power to AC power, AC power to AC power, and AC power to DC power. Now, from our power electronics concept, we know that whenever it is DC power to DC power, as given in the first choice, so it is a chopper. It is a chopper. So here you can see this DC power to DC power is the work of a chopper. Chopper is a circuit which will convert a fixed DC to variable DC. Similarly, when we have DC power to AC power, it is inverter. It is inverter. Then C is AC power to AC power. This we get in cycloconverter. Cycloconverter. And then D AC to DC power is your rectifier. Is rectifier. Now here, according to the question, inverter converts DC power to AC power. So it is going to convert DC power to AC power. So option B is the right answer. So here DC power is converted to AC power by an inverter circuit. Okay. And in this also the AC power which has been converted, it is at a desired voltage and frequency. So this is the basic definition of inverter. Inverter is a circuit which converts DC power into AC power at the desired voltage and frequency. In most of the inverters, both these quantities, that is the output voltage and frequency, are required to be controlled. Okay. So this is the basic definition, and here option B is the right answer, DC power to AC power. So here you can see inverter converts DC power to AC power. Then we'll go to question number 62. Line or commutated inverters have. Option A is AC on the supply side and DC on the load side. AC on both supply and load side. DC on both supply and load side. And option 4 is DC on the supply side and AC on the load side. So here option B will be the right answer because it is line commutated inverters. So it is AC on both supply and load side. So here you can see the explanation. Line or commutated inverters are actually phase controlled converters operated in inverting mode. They cannot act as standalone inverters as they require a AC supply. It is to be noted that line commutated inverter is not the conventional inverter. The conventional inverters are force commutated or load commutated inverters. Okay, whereas line commutated is one which will where the device which is going to switch on, that is the device which is going to control like SCR, will be commutated by the line, that is the AC supply. So here you can see it is having AC on both supply and load side. Line commutated inverters have AC on both supply and load side. Then we'll go to question number 63. In VSI, that is voltage source inverter, options are the internal impedance of the DC source is negligible. The internal impedance of the DC source is very, very high. The internal impedance of the AC source is negligible. The SCRs are fired at 0 degrees. Okay. Now, if you remember the definition of voltage source inverter, okay, voltage source inverter, it is fed from a constant DC source. It is fed from a constant DC source of negligible impedance. So here, constant DC source with negligible impedance. The internal impedance of DC source is negligible. That is, option A is the right answer. So here you can have a voltage source inverter is the one in which the internal impedance of the source is negligible. It has a stiff DC source at its input. So here option A is the right answer. The internal impedance of the DC source is negligible. Then we'll go to question number 64. Dash-based inverters do not require self-commutation. Now, dash-based inverters, so inverters based on IGBT, inverters based on GTO, inverters based on PMOS FET, and inverters based on SCR. Okay. Now, if you see the first three, that is IGBT, GTO, or PMOS FET, they can have some gate or base type of control a terminal where if you give appropriate voltage, it can commute, it can become off, so it can have self commutation. Whereas SCR, uh, it- if it is working on DC sources, it needs forced commutation. So here the answer is SCR. Option D is the right answer. Dash based inverters do not require self commutation. So SCR based inverters do not require self commutation. So here explanation. All the devices can be turned off by their gate or base signals except SCR. SCRs require external commutation circuits. So here option will be SCRs. So option D, SCR is the correct answer. Then we'll go to question number 65. Identify the circuit given below. Now in this circuit, we see two SCRs and we see two diodes. So two SCRs are going to work as your half bridge inverter. So here you can have your input. This is your input. This is also input. So here you are having your SCR1. This is SCR1 and this is SCR2. SCR2, and these are your freewheeling diodes. Okay, now here SCR1 and SCR2, this we can connect it like this again. So here SCR1 and SCR2 will form the half bridge. So it is a half wave bridge inverter. So here option C will be the right answer. It is the half wave bridge inverter. So it is a half wave circuit as it has only two SCRs are connected. It is a half wave bridge type thyristorized inverter. So here you can see option C is the right answer. It is half wave bridge inverter. Then we'll go to question number 66. Single phase half bridge inverter requires DC wire AC supply, 2 wire AC supply, 2 wire DC supply, 3 wire AC supply, or 3 wire DC supply. So if you remember the circuit of half bridge voltage source inverter, you can see we had a voltage source here like this, and then we had a load here, and then here we had a voltage source like this. Okay, and then here we had our SCR1. This was our SCR1, and then here we had SCR2, and this was a circuit, and here you have your diodes. So here you can connect your diode. So here you can have your freewheeling diodes. So here diodes. So these are load. This is your load, and this is the input supply plus minus plus minus. This supply will be of Vs upon 2, and this will be minus Vs upon 2. Okay, so both are Vs upon 2, Vs upon 2. Now here, if you see this supply, this is 1, 2, and 3 wires. So 1, 2, and 3 wire supply. So it is 3 wire DC supply. So here option D will be the right answer. It is a 3 wire DC supply. This is very important for half bridge inverters because it is one of the demerit also. Okay, so it is a very important concept of half bridge voltage source inverter. So they require voltage sources Vs by 2 and Vs by 2. So it is 3 wire DC supply what is required by half bridge inverters. Then we'll go to question number 67. In a single phase half wave inverter, okay, SCRs are or is gated at a time. Okay, single phase half wave inverter. In a single phase half wave inverter, we are going to get output like this. Okay, output will be like this. Whatever we are going to get, this will be the output. Now this output is going to vary from minus Vs by 2, 0. This is plus Vs by 2. Okay. Now this part is coming when SCR1 is gated. SCR1 is fired. This part is coming when SCR2 is fired. Again, this part is coming when SCR1 is fired. Okay, that means at a given time, only one SCR is fired. So here in this question, in a single phase half wave inverter, dash SCR or SCRs are or is gated at a time. So it is one SCR at a time. There are two SCRs in the circuit, but one SCR is fired, is gated at a time. So option is 1. So here only one SCR is gated at a time. Gating the both of them will short the supply. So your option A1 will be the right answer. Then we'll go to question number 68. The voltage in a single phase half wave inverter varies from. So as we know, the output waveform of a half wave, okay, half wave inverter, that is half bridge inverter. So here you can see the output waveform as we have shown earlier. It will be like this. This will be the output waveform depending upon the working of SCR1 and SCR2. This is your zero line. This will be plus Vs by 2, and this will be minus Vs by 2. Okay, so the voltage in a single phase half wave inverter varies from plus Vs by 2 to minus Vs by 2. So option C is the right answer, Vs by 2 and minus Vs. So it varies between minus Vs by 2 and Vs by 2 as the upper and lower SCRs are fired in sequence. So here you can see option C is the right answer, Vs by Option C is the right answer, Vs by 2 and minus Vs by 2. Then we'll go to question number 69. Single phase full bridge inverter requires. So in a single phase full bridge inverter, now this circuit will look like this. You will be having a voltage source DC here, which will be the input. Here you will be having your SCR, and here you will be having your one more SCR, second SCR. Okay, and for these SCRs you have the freewheeling diodes. This will be the diode here, and this will be the diode here. This will be the diode here. This will be the one part. Now here you can have your load. Here you can have your load, and then after the load again you can have the bridge connection, which will make it as a full wave bridge. So full wave bridge connection. So here you can have a SCR. So here you can have a SCR. And then for these SCRs, you can have your freewheeling diodes. So this will be the diode here, and this will be the diode here. So if you see a full bridge rectifier, so it will be having 4 SCRs and 4 diodes. 1, 2, 3, 4 SCRs and 1, 2, 3, 4 diodes. So option B will be the right answer here. 4 SCRs and 4 diodes. So full bridge inverter requires 4 SCRs and 4 diodes along with a 2-wire DC source. So your option B, as we have seen earlier, 4 SCRs and 4 diodes is the right answer. Then we'll go to question number 70. Identify the circuit given below. Now this circuit is the same as we have drawn. It was a full wave bridge inverter. Okay, it is a full wave bridge inverter. So here you will be having your DC supply. Now this DC supply will be converted into AC across the load, and across the load you will get a waveform like this. This will be your waveform across the load. So it will be positive, negative voltage. The voltage will vary between Vs and minus Vs. And because it is fully controlled, it is having 4 SCRs and 4 diodes. So it is full wave bridge inverter. So from this option, option C will be the right answer, full wave bridge inverter. So here you can see option C is the right answer, full wave bridge inverter. Then we'll go to question number 71. The output voltage from a single phase full wave bridge inverter varies from. Now, as we have seen the output voltage, so output voltage, we remember that the output voltage is shown as the alternating quantity like this, alternating quantity. So two SCRs will be fired and one of this positive or negative cycle you will be getting. Now this voltage varies from minus Vs to plus Vs. Okay, so minus Vs to plus Vs or plus Vs to minus Vs, anything you can call. So here option A will be the right answer. It is Vs to minus Vs. So here you can see the output from a full wave bridge inverter varies from Vs to minus Vs. So here option A is the right answer, Vs to minus Vs. Then we'll go to question number 72. In a single phase full wave bridge inverter, when the output is Vs or minus Vs. Okay, when the output is Vs or minus Vs, option A, one SCR and one diode are conducting, four SCR are conducting, two SCRs are conducting, two diodes are conducting. Okay, now here in a full wave bridge rectifier, for one half cycle to obtain at the output. So if you show the output like this, so if you show the output here, okay, now if you are having this output, okay, so here this is zero line, this is Vs, this is minus Vs. Now to obtain this part, two SCRs have to conduct. To obtain this part, the other two SCRs have to conduct. To obtain this part, the first two SCRs have to conduct. So like this, two SCRs are conducting when the voltage is Vs or minus Vs. So here, option C will be the right answer. That is, two SCRs will be arc conducting. So option C is the right answer here. So here you can have an explanation. When two SCRs are conducting T1, T2 or T3, T4, the output voltage magnitude is Vs. When diodes are conducting, freewheeling action is taking place and voltage is zero. So here two SCRs are conducting. Option C is the right answer. Then we'll go to question number 73. In the following circuit, the diodes D1 to D4 are used to. Okay, now D1, D2, D3, D4 are used along with their SCRs. You can see there are four diodes also. So those diodes are used for what? Option A is reduce the switching losses. Option B is send current back to the DC source when SCRs are off. Option C is send current back to the load when SCRs are off. Option D is send current back to the DC source when SCRs are conducting. So out of this, option B is the right answer. Send current back to the DC source when the SCRs are off. So that is the right answer here. Diodes are connected in antiparallel with SCRs during inductive loads for freewheeling action. So here option B, send current back to the DC source when SCRs are off. Then we'll go to question number 74. For a full wave bridge inverter, the output voltage is what? So option A is V0 is equal to Vs by 2 for 0 less than T by 2. Option B is V0 is equal to Vs for 0 less than T by 2. V0 is equal to Vs for T by 2 less than T less than capital T. V0 is equal to minus Vs for T by 2, that is half time period less than T less than 3 by 2 T. So here we should first remember the waveform, how it looks. So here you can see the waveform looks like this. This is positive half cycle, negative half cycle, positive half cycle, negative half cycle. Okay. Now here, this is your complete time period T. So this is 0. This is T by 2. T by 2. And this is T. Okay. Now from 0 to T by 2, it is Vs. And from T by 2 to T, it is minus Vs. So here output voltage is Vs from 0 to T by 2. So here this option 0 to T by 2. So it is output voltage is Vs. So this option B will be the right answer here. V0 is equal to Vs for 0 less than time less than T by 2. So for the first half cycle, V0 is equal to Vs, and for the second half cycle, V0 is equal to minus Vs. So option B will be the right answer here. V0 is equal to Vs for 0 less than T by 2. Then we'll go to question number 75. For a half wave bridge inverter, the output voltage is what? So options are given as V0 is equal to minus Vs by 2 for 0 less than T by 2. V0 is equal to minus Vs by 2 for T by 2 less than T for the full time period. V0 is equal to minus Vs for 0 less than T by 2. V0 is equal to Vs by 2 for T by 2 less than T less than full time period. Okay, so here again, if you remember the output waveform for a half wave rectifier, so you can see that output waveform when you draw. So here you can see you will be having the alternating quantity at the across the load. So this alternating quantity, you see that it is from 0 to Vs by 2, and this is minus Vs by 2. Okay, so it is 0 to, this is your T by 2, and this is T. So this complete is T. Okay, and this is your T by 2. So for 0 to t by 2, it is Vs by 2. And from t by 2 to t, it is minus Vs by 2. So here in this options, if you see, it is minus Vs by 2 for t by 2 to t. So from here till here, it is minus Vs by 2. So option B will be the right answer. Output voltage is equal to minus Vs by 2 for the half time period to the full time period cycle. So here in case of half wave inverter, for the first half cycle, V naught is equal to Vs by 2, and for the second half cycle, V naught is equal to minus Vs by 2. So here option B will be the right answer. V naught is equal to minus Vs by 2 for t by 2 less than t less than the full time period. Then we'll go to question number 76. In a half wave circuit, forced commutation is essential when options are the load is inductive, load is resistive, source voltage is below 150 volt, none of them mentioned. So here the answer is load is resistive. In a half wave circuit, forced commutation is essential when the load is resistive. So you have an extra circuit which can make the SCRs off when the load is resistive. So here, when the load is resistive, the diodes do not conduct. Hence, they cannot help stop the conduction of the SCRs. Hence, forced commutation in such cases become essential. So here option B will be the right answer. Load is resistive. And then we'll go to question number 77. In VSI, voltage source inverters, both voltage and current depend on the load impedance. Only voltage depends on the load impedance. Only current depends on the load impedance. None of the above mentioned. So if you remember the definition of voltage source inverter, it is fed from a constant DC source of negligible impedance. Okay, now in that case, only current depends on the load impedance. Okay, because it has a constant DC source, that means it will be only current which depends on the load impedance. So option C will be the right answer here. So in VSI, the voltage is independent on the load impedance Z, and therefore option C, only current depends on the load impedance. Then we'll go to question number 78. In a voltage fed thyristor inverters, dash commutation is required. Voltage fed SCR inverters, okay, forced commutation is required. So you have to at some regular intervals forcefully with an extra circuit, you have to stop the SCR working. So it is forced commutation which is required. So option B will be the right answer here. In voltage source inverter, the input voltage source Vs keeps the SCR always forward biased. Hence, forced commutation becomes essential. So here option B, that is forced commutation, is the right answer. Then we'll go to question number 79. The McMurray circuit is a options are a commutation circuit, force commutation, voltage source inverter, self-commutated voltage source inverter, none of the mentioned. Okay, so we have studied a parallel inverter, okay, in our industrial automation subject, which was popularly known as McMurray Bedford inverter. Okay, now this inverter is one where forced commutation is used. So it comes under the category of forced commutation VSI. So option B is the right answer, forced commutation VSI. So McMurray is a popularly used force commutated VSI circuit. So your option B is the right answer, force commutated VSI. Then we'll go to question number 80. In a half-wave bridge inverter circuit, the power delivered to the load by each source is given by. Okay. Now here the power delivered to the load in a half-wave bridge circuit. So in half-wave bridge circuit, we have seen that there were two sources of the voltage, and therefore the voltage will be, so if you see the voltage will be Vs by 2. Vs by 2, okay, multiplied by the current Is will give the power. So power is equal to Vs by 2 multiplied by the current Is. So here this can be written as Vs into Is upon 2. Okay, so there that means option B is the right answer, Vs into Is upon 2. So here power delivered by each source is Vs by 2, each is Vs by 2 into Is. So here you can see option B is the right answer, Vs into Is upon 2. That is Vs by 2 into Is is the power delivered to the load by each source in a half-wave bridge inverter. Thank you, students.